In this class, we'll show you how to prevent crucial private data, such as bank account routing numbers and credit card numbers, from leaving your network and from being inappropriately transmitted. Data leak prevention is required by some compliance regimes, such as PCI, DSS, and HIPAA, but other networks may also find it useful to help prevent, for example, student cheating. This class will explain sensor types available on your FortiGate. We'll also show you how to fingerprint documents to prevent specific files from being shared regardless of whether a user changes a file name. Finally, we'll also show you how to archive messages and documents that people are sharing on your network. This class teaches data leak prevention. It'll show you which data types can be monitored and how to configure DLP filters and sensors, and then how to add those sensors to firewall policies in order to activate DLP. FortiGate has other features such as IPS and antivirus that can detect and block files. What makes DLP different? Why should you use it? Traditional firewalls and first-generation UTMs were designed to prevent attacks and nuisances from getting into your network. Web filtering is only applied to traffic coming in. Likewise, despite best practices to apply it in both directions, many people apply antivirus and email filtering only to traffic coming in. But DLP is to prevent specific data from getting out. How can traffic that is leaving your network affect security? Often, it's normal to share sensitive documents and information inside your network, especially between servers that work together to host a single application. But if sensitive data, such as financial information, becomes public, it can have serious effects. Stock prices, bank transactions, privacy, and password security can all be impacted. So DLP helps to ensure that your network follows the rules required by your organization and doesn't give out important information. So how does DLP work? FortiGate scans traffic matching your firewall policy for the DLP patterns that you specify. When you configure a pattern, whether predefined or custom, DLP doesn't directly inspect traffic itself. Instead, it communicates the patterns to the proxies or IPS engines processes which actually do the scanning. So remember that when troubleshooting, you may need to investigate flow through modules that you didn't manually enable. If the scan finds a match, it executes the filter's corresponding action. So in the example here, the first two filters didn't match the file, but the third one did, so its action occurred. Now that we've seen the basic idea, let's start from the beginning, show how to add filters in a DLP sensor. Initially, we'll use some default file filters and message patterns. Later, we'll show how to customize and expand them. Most DLP behavior is dependent on the filter type, so we'll show that in depth. But first, let's briefly see the service inspection in action. First, change the GUI menu setting to show DLP. By default, it's hidden. To show it, go to System, Config, Features. Then go to the DLP submenu that is now available. Security Profiles, Data Leak Prevention, Sensor. Create a DLP sensor. Inside it, add a filter. In each filter, we'll specify which protocols to scan, match criteria, actions that FortiGate will apply when traffic matches. In the Examine the Following Services area, choose which network protocol should be scanned. Like with other security features, secure protocols aren't in the list of scannable network services. However, if you enable SSL SSH inspection, FortiGate will scan each protocol that you choose and its secure equivalent. For example, if you mark the checkbox for HTTP, FortiGate will also scan HTTPS. Notice that the options correspond with FortiGate's proxies. These are modules that can understand and parse those protocols So when you filter, DLP will match the payload, not inadvertently match parts of the protocol itself. You can enable flow-based DLP if required through the CLI. For each filter in the DLP sensor, you must indicate the action, what the FortiGate should do if the traffic matches. The default setting is log only. If you're not sure which action to choose, this can be useful initially. Select it while you study your network to see what sensitive information is being transmitted, then later select the most appropriate action to block sensitive files from the WAN or quarantine. Now let's return to the top of the filter, which is the more complex part of the configuration. Choose the type either message or files. Messages scans for words, credit card numbers, or other text-based patterns. If the predefined DLP patterns don't match exactly what you're looking for, you can use the regular expressions options to configure a custom pattern. Use PCRE syntax. Supported expressions and performance with complete expressions vary by the regular expression engine, so if you're looking for references, look specifically for PCRE, not others such as the similarly named Perl language. File changes the available options to be appropriate for files such as file size, fingerprinting, and watermarking. If you choose a file type for the filter, the file type included in option becomes available and has a corresponding drop-down menu where you'll select the file name which file names and/or file types to scan for. These refer to a group of file name and type patterns in security profiles, data leak prevention, file filters. Here is an example file filter table that matches all Microsoft Office files. Notice that to do this, it contains subfilters of both types. This is because older versions of Office use a binary file format identifiable by a binary file type scan. Office 2010 and newer files are not binary, but a zip archive. They are actually XML files inside a zip archive. This is documented on the Microsoft website, but the link here is easier to read. It's crucial to realize that because Office 2010 uses a nested file type, if you use file type filters with them, they will accidentally match any zip file, not just Office files. This is a common DLP misconfiguration. So to avoid false positives with these newer versions of Office, the default profile matches by file extension instead. Note, however, that the trade-off is possible false negatives. Let's explain the file-specific subfilters. File name patterns are intuitive if a file name either matches literally or matches the pattern, then FortiGate will do the action. As a result, if an important file name varies, which is usually the case, users may intentionally try to evade DLP by renaming files to a harmless sounding name. Then you should use patterns, not the literal file name. Configure FortiGate to match all intended file names, but no unintended file names. For example, browsers often rename downloads of duplicate file names to prevent accidentally overwriting an existing, different, yet identically named file. Before the file extension, for example, they would add to. Likewise, Windows renames copies of file so that they start with copy of. So usually, you should use a name pattern such as nicepainting*.jpg, not the literal file name nicepainting.jpg. The example here shows which filters would match the file name and which filters wouldn't. But what if the file name doesn't match any pattern? What if the file name is radically different and therefore a broad pattern would cause false positives? What if we want to block all executables regardless of name or platform, for example? File name matching alone is often not enough. You may want a more sophisticated filter. One addition or alternative is to use file type filtering. File type matching behaves as you'd expect. This is because file types are identified not by the extension such as .doc. Users could try to circumvent DLP in that case by simply renaming the extension. Instead, FortiGate enforces file type scans by searching the binary for signature patterns, how that file type stores data in specific areas, in specific patterns of ones and zeros. The trade-off for this accurate technology, however, is that unless FortiGate has a corresponding decoder that understands the binary data structure, it cannot decipher the string of zeros and ones, and therefore cannot identify the file type. To return to our DLP sensors filter, when scanning files, types, and names aren't our only option. On most networks, it's typically not an option to block all Microsoft Office files, and blocking by file name is not effective if users intentionally try to circumvent. What other alternatives do we have? FortiGate can use a content-based filter called document fingerprinting. Fingerprinting identifies specific files via one or more CRC checksums, so it's best used with files such as secure PDFs and photographs, files whose contents do not change or that don't change much. But fingerprinting can sometimes be configured for files that occasionally do change entirely, such as expense spreadsheets. We'll show that next. The file itself is not stored in memory, only the checksums. So you can fingerprint many or very large files. How accurate is the fingerprint? How many checksums DLP will calculate and store? Smaller chunks mean that more checksums will be calculated per file, so DLP will fingerprint more accurately. It will still be able to identify a file even if someone changes it in a few places because the checksums of the other chunks will still match. The trade-off is that more checksums require more FortiGate memory for storage, so you must decide the best balance between performance and accuracy. Now let's configure fingerprinting. Before you actually make any fingerprints, consider whether you'd like to make custom sensitivity level tags. For example, you could make a custom sensitivity level named Finance, then next, while configuring fingerprints, tag all money-related fingerprints. The sensitivity level will have two effects. The first, it will appear in log files. The second is when you configure each filter in a DLP sensor, you will select which fingerprints the file filter will use by specifying a sensitivity level. All fingerprints having that sensitivity level will be included in that filter. For example, if you configure a filter in your DLP sensor to be a file type, the File Fingerprint option appears. When you select it, its drop-down menu then becomes available. In the drop-down, you choose whether the filter will use critical, private, warning, or your own custom group of fingerprints according to their sensitivity level tag. Once you've defined any custom sensitivity levels, you're ready to define your fingerprints. Fingerprinting can be done two ways. In the GUI, you can upload files to the FortiGate so that it can create and store checksums. You can also configure the FortiGate to connect to a file share. If you prefer, it can do this periodically. Each time, FortiGate can automatically recreate checksums for all files in the share or retain old fingerprints in case an old version of the file is still circulating. Fingerprinting via file share is useful if you must add many files or if your files change periodically or extensively. That way, you don't need to manually update the fingerprint each time the file changes significantly. While configuring either method, choose which sensitivity level FortiGate will use to tag those fingerprints. After fingerprints are defined, go to a DLP sensors filter where the type is file and file fingerprint is chosen and select a file sensitivity level. So now we've configured a few filters in the DLP sensor. Continue with more filters until the sensor matches all traffic that it should, but doesn't match unintentionally. Finally, apply the DLP sensor by selecting it in a firewall policy. Here is an example DLP sensor with a few filters. Each filter searches traffic for different types of sensitive information, such as credit card number or fingerprint. If traffic matches a filter, FortiGate will apply that filter's action. Remember, DLP filters are evaluated for a match sequentially, from top to bottom, and FortiGate uses the first matching filter. So for example, let's say an email contains a credit card number, which filter 1 says to block, but also has sensitive text, which filter 5 says to log but allow. FortiGate will only use the first filter. The email will be blocked, not allowed. Up until now, we've shown DLP blocking or monitoring sensitive data. What else can DLP do? It can record traffic summaries, that is, logs, and if enabled, the full files and messages. If you were familiar with content archiving on older versions of FortiOS, you will recognize summary archives and full archives here. Summary archiving records a log message that summarizes the traffic and therefore will vary by protocol. For example, with an email message, the summary archive would contain the sender's email address, the recipient's email address, and the size. Full archive records the summary log but also a complete copy of the traffic. This can be very useful in forensic investigations. It's not meant for prolonged use, however. Depending on what you're archiving, full archiving can require large amounts of disk, CPU, and RAM resources. This will decrease FortiGate performance. For example, if you fully DLP archive a 100 megabyte file, FortiGate will actually store more than just 100 megabytes. It stores the data plus Ethernet, IP, and other headers that were used during network transmission, plus the log messages. So it will require slightly more than 100 megabytes. But also, this requires RAM and CPU until the FortiGate finishes writing the file to its hard disk. Full DLP archiving also consumes limited disk space that the FortiGate may need for other UTM features. So for performance reasons, it's better to use a FortiAnalyzer or external storage device. If you need to inspect and archive email, especially for prolonged times, then FortiMail may be a better alternative. It has local archiving, plus many anti-spam, secure messaging, and other in-depth features that FortiGate's SMTP proxy cannot support. Now it's time for the labs. In this lab, you'll block files based upon file type, block credit card information, and set up fingerprinting.